Recording in progress.
Question 9 reads, an aerial view of a stretch of road is shown in the diagram below. The road can be described by the function y is equals to x squared plus 2, given that x is greater or equal to 0. And that's if the coordinate axes are chosen as shown in the diagram. Benny sits at an vantage point B, which is 0 and 3, and observes car P traveling along the road. They want us to calculate the distance between Benny and the car when the car is closest to Benny. If you look at your answer sheet, there's about 3 ways you can do this. We'll go through the first 2. Now, the distance between Benny and the car can be calculated using the distance formula, right? And we know that's going to be BP squared is equals to x2 minus x1 squared plus y2 minus y1 squared. Now to find our points, point 1, we'll just go ahead and use B, which is 0 and 3. And for point 2, we have to use P. Now, we do not have an actual x value or a y value, but we'll assume there exists an x value that corresponds to a y value that says x squared plus 2, right? Okay, let's go ahead and put that in as our coordinates.
Recording in progress.
Let's go ahead and substitute these points into our equation. So we will have x minus 0 squared plus x squared plus 2 minus 3 squared. For the first part, we will get x squared plus, let's just simplify that part first before we expand. Let's go ahead and expand. We're going to square the first one. Multiply these two together. So x squared multiplied by a negative 1. Then multiply that by 2, giving us minus 2x squared. Then square the last one, which will just give us 1. Let's go ahead and simplify it. And, you're going to get minus x squared plus 1. So we're going to make an assumption that when BP is at its minimum, so is BP squared. Reason B, it can be very difficult to calculate, to differentiate a square root. So it will be better for us to just work with the BP squared. Let's go and calculate the gradient of our BP. So we're going to differentiate the BP squared. And we get 4x cubed minus 2x. And we know that when the gradient is equals to 0, that's where our minimum or maximum lies. So we'll go ahead and equate that to 0. We can take out 2x as a common factor. Okay. This will leave us with either 2x is equals to 0 or 2x squared minus 1 is equals to 0. Here we can say x is equals to 0. Take 1 to the other side. 2x squared is equals to 1. Divide by 2. X squared is equals to a half. Then the square root of x squared will then give us 1 over x squared. So the reason why we don't use the negative part is that at the beginning they did say that x can either be equal to 0 or must be greater than 0. So we're not going to take the negative part of our square root. Now, they simply say that x is equals to 1 over the square root of 2, but I would suggest that you substitute in both values to see which one is the minimum. Now, you can actually, in this case, you can actually use it to calculate your value BP instead of BP squared, because you understand that it's just going to be the square root of BP, or BP squared, I mean to say. So here we have our BP squared is equals to x to the power of 4 minus x squared plus 1. We'll substitute in first the x is equals to 0. So we get BP squared is equals to, okay, let's just use BP, the square root of 0 to the power of 4 minus 0 plus 1, and that should just give you 1. And we're going to go ahead and substitute in the 1 over the square root of 2. So BP would be equals to the square root of 1 over the square root of 2 squared minus to the power of 4 minus 1 over 2 square root squared plus 1. And that's going
Recording in progress.
square root of 3 over 2. Clearly, that giving us 0.87 is lower than 1, and that will then be our minimum. So this is the closest distance between the two, right? When x is equals to that. Let's go ahead and look at the second method.
Recording in progress.
So for method 2, we are going to say that the shortest distance between these two will exist when the gradient of our graph or our road is perpendicular to the point B. So we are saying something like this. Let's show it on the graph that this, we do believe that, well, imagine that this was on B. That didn't go so well. Let's try that one more time. Yeah, so kind of imagine it is on B. It's really hard to control this pen. And we are saying when the graph is tangent, or the tangent of our graph is perpendicular to the point B, then that would be our shortest distance, right? So we'll call the gradient of BP line. So imagine the point is now here. We'll call that M1, and we'll call that M2. So we are saying that M1 multiplied by M2 must give us -1. So what is the gradient of M2? We know we can get the gradient of M2 by just deriving our dy dx. So that would give us 2x. And for M2, the gradient, we will use a change in y over a change in x, sorry. So for the B point, we already know our point 0 and 3. And for our P point, we say we have an x value, right there, that will correspond to a y value given by the equation x squared plus 2. So that is our P point. So let's go ahead and calculate that. We would have, let's say that this is 0.2 and that is 0.1. Really doesn't matter. At the end of the day, everything is going to have to be the same, right? Well, whichever one you choose as 0.1 or 0.2. For our answer, they had chosen this as 0.2 and this one as 0.1. So let's go ahead and use that. So we have, for our y values, we have x squared plus 2 minus 3. And for our x, we will have x minus 0 which will leave us with x squared minus 1 over x. So now, going back to this equation, we will have x squared minus 1 over x multiplied with 2x must be equal to negative 1. We will divide both sides by 2x, divide both sides by 2x. Then we would get, let's move up a bit. We will get that x squared minus 1 over x is equals to minus 1 over 2x.
Recording in progress.
We will go ahead and cross multiply. So we have 2x, x squared minus 1, giving us x.
Recording in progress.
Multiplying out, we have 2x cubed minus 2x is equals to x. Well, taking this to the other side, we get 2x cubed plus x is equals to 0. Let's take out x as a common factor. We have x, 2x cubed sorry, let's fix this part. It's supposed to be a minus 1. There we go. Minus is equals to 0. Then we're going to have is either x is equals to 0 or 2x squared minus 1 is equals to 0. Okay, and we will have x squared is equals to 1 over 2, and x is equals to 1 over the square root of 2.
Recording in progress.
Now, to calculate the minimum distance, they used the distance formula that we used in method 1, and you will see how the answers are the same.